Here, this is a general consideration of so pipelining. So here, some jobs we are dividing. Some jobs we are dividing into four segments: S1, S2, S3, S4. In the previous class, we have studied that any jobs how we can divide into different segments, so that here we are considering as a first segment is S1, second is S2, S3, S4, and this is a registers connected between two segments. Okay, so whatever the operations performed by these segments, that results will be given to this register R1 when you apply the clock pulse. So during that clock pulse, application of clock pulse, this unit also, the results performed by this segment is given to R2. Similarly, the sub operations performed by S3 is given to R3. Sub operations performed by S4 is given to R4. This S1, S2, S3, S4 will perform the sub operations. In the previous class, we have studied how sub operations we can design it. Okay, you right now, okay, it consists only four segments. Assume that we are passing an operands through from here. So the entire job is completed. One is completed when it passes through all these four segments. So four sub operations will be carried out, and finally we are getting the results. So the collection of four sub operations we consider as a one task, means to perform a one task on given operands, we need to perform four sub operations. Okay, so here we have shown this. Okay, so assuming that we need to perform six tasks, in the sense six jobs we need to perform. So each one job, remember, is divided into four segments. Okay, sub operations or segments. Okay, assume that the first task we are the operands of the first task will enter here. The first task, first sub operation is performed in S1, and after application of clock pulse during the first clock period. Okay, so we can see or some time slot, first time slots after application of clock pulse, the operations performed by this sub operating unit is given to R1. So it is shown here. This table is a space-time diagram for a pipelines. Okay, so this 1, 2, 3, 4, 5, 6, 7, 8, 9 is talking about clock cycles. In the first clock cycles, what's happening we are checking, and rest clock cycles also. And these are talking about segments. Okay, these are the segments: 1, 2, 3, 4 segments. Okay, in the first clock period, what is happening means, so task 1, the input operands belongs to task 1 will enter here, so that a sub operation related to task 1 is performed by S1. Okay, in the next clock period, what happens? The sub operations performed by this S1 on the operands belongs to task 1, and intermediate result is here is given to that S2. So second sub operations of task 1 is performed on operands during the second clock periods. It is shown here. At that time, this unit will not keep idle. It will take the operands of the task 2 and first sub operations of task 2 will be performed. Similarly, in the third clock pulses, so what happens means the results from R2, output of an R2 is given as an input to S3. Third sub-operation of a task 1 is performed by S3. Second sub-operations of task 2 is performed by S2. First sub-operations of task 3 is performed by S1. That is shown here. So in the task 3, S1 is performing the in clock 3 so S3 is performing the third sub operation of the T1. Segment 2 is performing the second sub operation of task 2. The segment 1 is performing the first sub operations of the task 3. Okay, like that it continues. Okay, so what happens then, we'll see here. So in the fourth clock periods, fourth clock periods, what happens means fourth clock period, the last sub operation of task 1 will be performed here. The third sub operation of task 2 will be here. Second sub operation and the first sub operation of task 4 will be generated. Done by these units. Okay, in the fifth, what happens means, now the job is over. One job is over, in the sense task 1 is over. That's the reason task 1 takes how many clock periods? 4 clock periods to complete. Okay, so first task 1 is completed after fourth clock cycles. Okay, in the fifth clock cycle, same thing, T5 will enter, so T2 will be here. In the sixth clock, T6 will be enter, the T3 will be here. So then, okay, assume that we have given only 6 tasks, like this, totally 9 clock cycles it requires. 9 clock cycles we requires here. Okay, so see here, so we need to make one general rules for that. Okay, so we'll consider this TP is a clock cycle time, means how much time it takes to perform a one sub operations, means we assuming that here now in between 2 clock pulses, after one sub operation will be happening. Now what is the time period between the 2 clock pulses? In time duration means 2 clock pulses, in the sense between I said, or else you can say that what is the total time period of one clock pulse, that is called as TP, clock cycle time, the total time of the 1 clock cycles. The first task 1 T1 requires time K into T. So forget about this part, this we'll talk about later. Okay, so now the first task T1 requires time KTP, means here we have said 4, so that's the reason 4 clock cycles. This TP you consider as a clock cycle. So if this you have a 6 segments, then it is 6 clock cycles. So first task will be completed after 6 clock cycles. If you take a 6 segments, here we are considering only 4 segments. That's the reason first task will be completed after 4 clock cycles. Okay, so 6 tasks T1 to T executed in 4 segments we are considering for that. That's the reason. See here what happens. So the first task T1 is completed after 4th clock cycles, correct? The first task T1 will be completed after 4th clock cycles, and the second task, so in the very next clock cycles itself, the second task will be over. Second task will be over. Correct or not? So second task will be over. See somewhere here. So S4 is a segment. You can see that as the, so now the first task is over. In the next, so totally we have, it has taken 4 clock cycles to complete the first task. Very next task will be completed after, just after 1 clock. So time taken to complete the 2 tasks is 4 plus 1. 4 plus 1, that is 4 plus 2 minus 1. 1 I can say 2 minus 1. The time required to complete the third task is how much? First 4, then 2, then 2. That is 4 plus 2. That is 4 plus 2 means 4 plus 3 minus 1. The time taken to complete the fourth job is, fourth job or task is 4 plus 3. 4 plus 3. 4 plus 4 minus 1. So this is fifth job. Time required to complete is 4 plus 4 plus 4 plus 4 plus, then here 4, that is 5 minus 1. So 4 plus 4, 4 plus 5 minus 1. In the same way, time required to complete the sixth job is these 4 clock cycles, then these 5, means 4 plus 5, that is 4 plus 6 minus 1. So that's the reasons I can say that time required to complete n task is total 4. This 4 means we have 4 segments. That's the reason 4. This is K is talking about 4. Number of segments plus how many task is there. If I am having a 6 task, then this number whatever added is 5. That is 6 minus 1. If I have a n task, then I should add n minus 1. So K plus n minus 1 TP. TP is, this is a clock period. K plus n minus 1 TP. This is a whole bracket. Okay. So this is whole brackets. So here this is whole bracket. So that is a thing here. Okay. So time required to complete n task is, that's a reason K plus n minus 1 TP. Okay, here. Okay, next. So we can see that how much speed up will happen because of this this kind of architecture, pipelining architecture. So assume that we have seen that time required to complete n task is K plus n minus 1 TP. You consider that TP is a clock periods. So assume that we don't use this such kind of pipelining. Then assume that some TP is required. Time P is a this T1 is a time required to complete that job. So this not T1. You can say request KTP. I will give that. Sorry, this is not this T1. This TN. This TN is a time taken by the non-pipeline unit to perform this. So means if assume that same operations. So I don't use this kind of a sequential networks. So without means pipelining networks. So I will do this 4 operation without using this pipeline. Then each task requires T1. Each task requires T1. If I am having a 4 job means 4 Tn. Assume that is a without using this pipelining architecture. If I have a 4 jobs is there, I require 4 into Tn. Assume that time Tn is a time required to perform that sub operation without utilizing the pipelining architecture. Then it is NTN. So we are taking how much time it takes without using pipelining, and this is a time taken if you use a pipelining. This is a speed up equations. So as a summary, we will talk any operation that can be decomposed into sequence of sub operations of about the same complexity can be implemented by pipelining. Means any operations which you feel that it can be decomposed into some few sub operations, that I can do it of using pipelining. The technique is efficient for those applications that need to repeat same task many times with different sets of data. In some times, some job will be there. It consists of 4 sub operations, and that job we need to do for so many operands in that conditions and so many times. And so means job is same, only operands will be different, and we need to continue this for long so many times. In such cases, this architecture is very helpful. The operand pass through all 4 segments in a fixed sequence. In the sense, assume that this operand for first segment it passes through in 1 microseconds. In second segments also it passes through 1 micro, and third also 1 micro, and third also 1 micro. In such cases it is very suitable. Each segment consists combinational circuit SI performs a sub operations. As we seen that, so these segments consist a combinational circuit, and it will perform an operation on these inputs. The segments are separated by a register Ri through hold in intermediate results. Listen here, these are registers will hold the intermediate results. The information flow between the adjacent stages under the control of common clock applied to all the registers. So we are one common clock we are applying to all. At this time, each sub unit will pass the to registers, meaning that the register output is accessible to second unit. So during the application of clock pulses, information goes from one unit to another. But after that, this unit can perform its operation independently. It will not affect here until you apply another clock pulse. Usually it's an edge clock. If you use only during an edge, this output is passed to that, and later these are isolated. Each segment consists of we define a task as a total operation performed going through all segments. So one task means the total operations performed by all these subunits. So for an example, as I said, if you have a 4 segments and 6 tasks, the time required to complete all is k plus n minus 1, 4 plus 6 minus 1, it is 9 clock cycles. Okay, now